Now we are going to see about full wave rectification. Because the efficiency in half wave rectification is very less, so we want to use the negative half cycle also to convert into DC. So that's why we go for full wave rectifier. This is full wave rectification using two diodes, and we have full wave rectification using four diodes also. That is called bridge rectifier. But here we make use of a special type of transformer, which is center tap transformer. That means the idea is we have to step down the voltage. That's the main idea. So input side is 230 volts, 50 hertz AC. When you use a transformer, it steps down. For example, if you purchase 230 by 606 volts means with respect to center point, you have three terminals in the secondary. The center point, this end goes positive, say 6 volts, this end goes negative with same 6 volts only. That means when this end goes positive, this end goes negative. When this end goes negative, this end goes positive. Now, our idea is we need a DC supply across the load. So for that we have two diodes, D1 and D2. So let us assume this top end is going positive and the bottom end is going negative. So what happens is, when this is positive and this is negative, definitely diode D2 won't conduct. So you replace with an open circuit, and D1 will conduct, you replace with a short. Conducting means short. So now we are neglecting the forward voltage drop across the diode. For silicon diode it will be roughly around 0.6 to 0.7, and for germanium diode it will be 0.3. So we are not taken that voltage into account. So this positive diode starts conducting, it goes here, it comes up here, but there is no path here because it's an open circuit, no current will flow here. It goes here, and the current direction is from A to B through the load. Through B, here is these two wires are not connected, it goes to 0 and then to positive. It can't go this way because this path is totally open circuit. This is open circuit, therefore no current will flow in that path. So the circuit gets completed during positive half cycle. Now we will consider what happens in the negative half cycle. In the negative half cycle, this end goes negative and this end goes positive. That means we already have two diodes like this, and then here also we have two diodes. Okay. Now since this is positive, this is negative, definitely this will not conduct. So this will be replaced by an open circuit now, and this will be replaced by a short circuit now. So now this is positive, so current starts flowing through the diode. It goes up to here, but there is no path this way because diode is reverse bias and acts as open circuit. So current will go to A through the RL to B, and this end is not, two wires not connected, and it reaches 0 and the circuit completes like this. So now again you see the direction of current is from A to B, it has not been reversed. That confirms across through the load, the current flowing through the load is DC. In both the cases, whether it is positive or negative, in both the cases the current direction always remains same, that is from A to B. A to B means it is unidirectional. Unidirectional confirms DC supply. Okay. Now we will draw the input and output waveforms for this full wave rectifier. So the input waveform, so you have an input like this. This is time. This is voltage. Say Vm, maximum voltage, minus Vm. In the output, what's happening? We have converted both these cycles. That means positive half cycle, the direction of current is from A to B, it is unidirectional. From this point to this one, negative half cycle, it is unidirectional. It is not negative. That means here you see plus minus, it is an alternating source. Whereas through the load, the current flowing through the load or voltage across the load is unidirectional, all are positive. This confirms that we have utilized this negative half cycle also to convert into DC. That means both the cycles have been converted to DC. So always go for full wave rectifier. the efficiency of full wave rectifier is improved compared to half wave rectifier. Thank you.